with this pink covariance ellipse, uncertainty ellipse, and mean over here. And you can here see that it's actually a substantial difference to what the true distribution actually looks like. If you use the EKF, so example kind of 4 sigma points over here, transfer those sigma points, then you actually get the green Gaussian estimate over here. Again, it is not the true estimate, but it's closer to the true estimate just by visual inspection compared to the result that the EKF actually provides. So if we have highly nonlinear functions, the UKF can be a very interesting alternative to the EKF because it has better mean for computing the Gaussian approximation of the Gaussian propagated through a nonlinear function. So to summarize this a little bit up, so the uncentered transform is just an alternative to the linearization, and it's typically better than the Taylor expansion, what the EKF does, and kind of the advantages of the uncentered transform is for highly nonlinear functions. So instead of having one linearization point, which is the mean, the uncentered transforms adds additional points. So kind of the sigma point number 0 is the mean, and then it adds additional points to that and propagates these points through the nonlinear function and obtains a Gaussian estimate. There are 3 parameters in the uncentered transform, and because there's no unique solution for how to set the weights and how to set the sigma points. And we can use the uncentered transform in the prediction step and in the correction step of the EKF, and then we obtain something which is typically called the uncentered Kalman filter, UKF. If we compare the results of the UKF and the EKF, they give you the same results for linear models. There may be numerical issues, so you're not free of numerical issues always, but if you have high precision in what you can compute, you should get the same result if you run the EKF and the UKF for linear models. So for linear models, we should get the same results. For nonlinear models, the UKF is a better approximation than the EKF. However, most people say with reasonably engineered robots, that means that the uncertainty is not extremely large in the motion, it's not extremely large in the observation. This difference is somewhat small. So you can see this, but it really depends on your application. So if you have a really, really crappy motion system of a robot, it may be worse to use the uncentered Kalman filter, but if you have a decently designed system, the difference to the EKF is really small. One advantage of the UKF, except that is that you don't need to compute the Jacobians. If you're kind of a little bit lazy or don't want to compute the Jacobians or it's additional source of error, you can skip that with the UKF. They're in the same complexity class, but the UKF is typically a little bit slower than the EKF if you really do an implementation, because you need to transform all those points. So in practice, UKF is a little bit slower, but the same complexity class. But again, we are still restricted to Gaussian distributions. The only thing that we do, we kind of get a better approximation of the underlying distribution through a Gaussian if we use the uncentered transform, except compared to the Taylor expansion for the linearization. If you want to know more about that, that's chapter 3.4 in the probabilistic robotics book, which is something which follows directly after the EKF in the book, which, as it was done here, explains what we have done here. The notations would be very similar to what I have shown here. There are 2 other books, or 2 other articles, not books, articles, which I found nice. So it's kind of the new extension of the Kalman filter to nonlinear system that by Julia and Ullmann. Julia is actually one of the guys behind the EKF. It's also a technique which is, say, reasonably new, so it's less than 20 years old compared to the Kalman filter, which dates back into the 50s. And there's also, I think it's a script of another lecture on dynamische Zustandsschätzung. You find it on the web in these 4 pages. It's in German, but for those of you who may prefer German literature, I found it actually worth reading. It was kind of well readable as well. Okay, so that's it from my side for the UKF, and we will now look into